David has an extensive history in business management and ownership and is an experienced and innovative senior executive leader and entrepreneur with over 30 years in a both commercial and nonprofit sector, covering environmental research and technology, healthcare, distribution, financial services, transportation, and a variety of other markets. He's a strong communicator and a strategic evangelist. I didn't write it. David is a strategic and creative thinker, always on the lookout for solutions that turn obstacles and ideas into real opportunities for innovation and change. He is an optimist that has successfully collaborated on projects addressing the biggest challenges of our times. David has always been interested in protecting the environment through sound business practices to yield sustainable outcomes. His business ventures have included the first green chemical drum recycling program, state-of-the-art atmospheric instrumentation development to monitor UV levels and ozone hole, as well as aquatic and terrestrial ecosystem health. David is at ease in science, technology, and business, and able to translate deftly between technical and business. Welcome, David.
Well, thank you, everybody. So as I mentioned, hang on. We'll go pretty quick through this, but I want to kind of address some comments that I heard back. I don't know if the gentleman, there he is. He's grabbing his coffee now. Because I want to raise the alarm level a little bit at the beginning of this. We're currently dumping about 110 million tons of man-made global warming pollution into the atmosphere every 24 hours. To put that in perspective, that's like exploding 500,000 Hiroshima-sized atomic weapons every day. 500,000 of those explosions every day. That's 6 explosions per second. That's how much heat we're putting into the atmosphere. Where's it going? We're starting to see, right? It's been invisible, but no longer. The largest source of that global warming pollution is burning fossil fuels. CO2 has been being released into the atmosphere faster than it has over the past 66 million years. So if you look at that just back 800,000 years of ice record that we've got, the CO2 concentrations that you see here, if we also map the temperature that we experienced, you'll see that they correlate pretty darn good. If I was a betting man, I would be saying there's something going on there. They're relating. And this is what we're currently at, 415. If we don't change right now, if we just continue on the track that we're on, this is what it's going to look like. In 40 years, just 40 years. That's like a remarkable impact on the planet. And we do need to be alarmed. And it's us that's doing that. It's not sunspots or the orbit of the Earth or the wobble and tilt of the planet or any of those things. It's humans taking fossilized carbon from under the surface of the Earth, bringing it up to the surface and putting it into the atmosphere. It's not cows, by the way. There were billions of bison in the plains of North America. Billions of them. They were all farting. They were all producing methane. It's the fossilized carbon that's extra in the atmosphere that's causing. This is the average from 1950 to 1980. Cold, warm, the average temperature. On a decadal basis, that's how this is changing. We are now experiencing more extreme heat events than we have cold days. That's just a rapid shift that we're seeing. This is the global surface departure. If we average from 1950 through 1980, that's why it's kind of on the axis. Prior to that, temperatures were cooler. Post that, temperatures are hotter. Sorry about the bottom graph there, but 18 of the 19 hottest years, 2019, have occurred since the year 2000. And the last 5 years replaced the previous 5 years as the hottest ever recorded. This is a time to be alarmed. This is not a time to sit around with business as usual. We need to take some drastic extra actions here. All of these things are happening now. I love this quote by Henry Pollock. Lana Pollock, actually, his wife, used to be the US co-chair of the IJC, the International Joint Commission that oversees the waters of Canada and the United States, the boundary waters. Ice just melts. Doesn't have a political stripe. The warming hiatus that people were talking about before, the denial industry, what happened there was if you take ice at 0 degrees and water at 0 degrees, it takes energy to do what's called a transition of state, to change from a solid into a liquid. I can have ice at minus 20 degrees and I can heat it up to 0 degrees, right? Ice isn't just 0 degrees. It can be different temperatures. That takes 1 calorie. That's how we define a calorie, is 1 gram of water increasing by 1 degree Celsius. How much energy is that? To go just at the same temperature, no change in the planet's temperature, it takes 80 calories just to change state. That's called the state of, or the fusion transition, right? That's why you can have the oceans and the glaciers and the ice on the oceans melting and see no temperature change, but you see a lot more water. We have about 1/3 of the world's glaciers. You might not have known that in Canada. 1/3 of them are in our country. And we're seeing a more rapid temperature increase in the north where the glaciers are than the average temperature you hear people talking about of 1 degree, the global average. We're seeing 3.5 degrees in the northern parts of Canada, and that's where the ice is. This is Siberia, 93 degrees Fahrenheit. That used to be like a place where people got sent to be punished, right? You're going to Siberia. Now it's like going to have a swim. And we know this summer that they were just experiencing tons of fires, as we were in our Arctic and in northwestern Ontario this summer, lots more fires. We are, as I mentioned, seeing an accelerated, the global average temperature might be increasing 1 degree, but because of circulation patterns and trapping of airflows and things like that, the actual experience is about 3 times higher at the poles than it is at the equator. So if you hear 1 degree, or you even hear we're trying to restrict the temperature increase to 1.5 degrees, that's like the global average. We will be trying to restrict temperature increases in northern Canada to 6 degrees, right? It's a huge reason why Canada needs to have a little more alarm. It's not all going to be down. I'm not all going to be depressing about this either, but it is a time to be alarmist. In mid-February of 2018, the actual normal vortex, the normal polar vortex it's called, the jet stream, the air that's up there, was all together in one piece. I'll show you what it actually looked like. This is kind of the normal jet stream circulation pattern we're looking at down on the North Pole. These vortex changes now are causing a wavier jet stream, and that's trapping things like hurricanes down in over the Bahamas, for example, these perturbations in the jet stream. Air temperatures that we had over the Great Lakes region were still icy cold, and we had ice storms, and we had lots more ice in 2014. But it's because that polar vortex that should be a nice little isolated spot up there is getting split and spread down. So those are changes that we're starting to experience more often. And that's the wavier jet stream look. And in those little waves, we start trapping these storms, and they sit on top of a Bahamian island that's maybe 3 feet above sea level, and they have 320 kilometer per hour winds for 2 days, nonstop, and a 26-foot sea surge that just wipes out their homes. And they're still missing how many thousand people right now? Missing, because they're not there anymore. They literally were washed off the planet, or washed into the ocean. We need to be alarmed. This is alarming. Because what we're doing is causing them to get washed into the ocean. We're connected. So we have to start this. Global ocean temperatures are increasing. We're measuring those. There's no hiatus. There's no listen to some of these senators down in the US talking about nothing's happening. Here's a snowball. Look, it's cold outside. That's just ridiculous. And we need to stop falling for that stuff. These are ocean heat waves. They're increasing. The science is really clear. And I could go on for literally 4 hours of slides that I have on my computer, if you're interested later on, to talk about those things, right? But we're seeing these, the downpours, these massive storms. Is that me still arrowing around? Yeah. These huge bathtubs of water sitting over. Here's an animation of what it looks like. Watch the splash. That's what's happening. So how's the city of Toronto or Sundridge going to build the infrastructure that can possibly hold that kind of water in that timeline, right? It's impossible. So globally, floods and extreme events now occur 4 times more often than they did in 1980. These are the precipitation anomalies. You can't argue. This is just science. There's no politics here. This is literally just scientific data. There's no, I'm a liberal, I'm a conservative, I'm a Republican, I'm a Democrat. This is just science. Somebody mentioned actually the ice-free days that they're experiencing, or the frost-free days, right? Yeah. So we're at about 14, plus 14 to plus 18 right now, frost-free days, over normal. Worldwide catastrophes, whether it's extreme temperatures, droughts, fires, floods, mudslides, and storms, they all cost billions of dollars, billions and billions of dollars. Ontario alone's had billions of dollars of costs incurred since 1980. And who pays for those things? Taxpayers. And what does that mean? Those dollars can't go into social programs or healthcare or schools or education or any incentives to move people off of fossil fuels and get them into things like electric vehicles. So that's the big picture of what is going on outside in the world. I want to bring it down a little more to where I work every day, which is in Georgian Bay. And what we're actually seeing there is about a 0.8 degree increase in the temperatures globally. We're more than double that. Our ice cover in the Great Lakes is down by about 71%. So it fluctuates, but on average, again, remember, the weather is what you see when you look out the window. Climate is what we see as scientists when we look at 30 years of data or 40 years of data. From the climate's perspective, we've got a 71% decline in ice. That's what it looks like. Again, lots of variability, but there's a trend that we're seeing. It also means not just the ice isn't there and people can't go out and skidoo safely. 16-year-old girl drowned this past winter. Prior to that, down in just off Port McNichol, 2 guys went through the ice at night because they are where they always used to skidoo. It used to be safe, but it isn't anymore. But also things like fish eggs are now not protected by ice cover on the shore. They're exposed through these winter storms with increased winds, and more of the fish eggs don't survive. That has impacts on First Nations fisheries, sustainable fishing, as well as commercial operations and recreational. Surface water temperatures up about 2.5 degrees Celsius, according to NOAA data. Great Lakes warming all through Lake Michigan, increasing. Water expands when it's hotter too, by the way, so that makes the water higher. Water levels go up just because of the heat. Wind speeds about 5% per decade. My marina in Midland, we had hurricane force winds for 15 minutes sustained. It blew our entire dock of boats about 25 feet towards the $1 million yacht row, which I'm not in, but I'm adjacent to. We almost were like running into the $1 million boats, dragging 3 5,000-pound concrete anchors. And we were facing into the wind. We weren't broadside, we were facing the wind. Huge amount of energy. So the regional trend that we're seeing regionally in Georgian Bay, and according to the Environment Canada folks, is that we are going to continue to see these increases in extremes. Hotter, bigger storms, hotter air each degree puts about 7% more water vapor into the atmosphere. Each 1 degree temperature increase increases the number of lightning strikes by about 10 to 12%. And we're seeing increases in forest fires because there's more lightning going on, right? I think there were about 1 million lightning hits this spring in northern Ontario, and we ended up with hundreds of fires burning up there. We're seeing wetter winters, less snow pack in the forest. More of it is coming as rain and it melts out, right? So here's some numbers I want to show you. Lake Michigan Huron outflow to Lake Erie, that's the St. Clair River, 189, that happens to be 1,000 cubic meters per second, but it's 189. The inflows from Lake Superior through the St. Mary's River are about 75. The land-based runoff, about 94,000 cubic meters per second, and the overlake precipitation is about 110. So all of those inputs come into Lake Huron and Georgian Bay in our watershed, and they flow out through the lake. 87,000 cubic meters per second, almost half of what you would see if you were going over the Blue Water Bridge to get into the States. About half of the volume that you see flowing through the St. Clair River is evaporating off the surface of the water. And most of that evaporation is happening during the coldest months of the year, when the thermodynamic driver takes the hotter water, the warmer water, into the colder air, right? It's like boiling a pot of water. Hot water into your air. People talk about diversions like Chicago taking all of our water and causing our water levels to go down. But we are also, don't forget, diverting water into Lake Superior from 2 rivers, the Agoki and Long Lac, where we reversed the flow, no longer into James Bay, but down into Lake Superior. 6,000 cubic meters per second. Chicago's only taking out about 3,500. So we are putting more water in, a little bit, but really it's climate. If that evaporation number changes, or if that precipitation number changes, those are the real things that are changing the flow. Lake Superior is a regulated lake, right? It's got a dam at the St. Mary's River. That's the water level of Lake Superior at the top since about 1918. In the bottom is Lake Michigan Huron, and what we're starting to see are these divergences. We're exceeding water on the high level, and we're exceeding it on the low level. 2013, all-time ever record low. This year in Lake Huron, we came really close to making a new high record. Lake Superior, Lake Erie, Lake Ontario actually hit record levels. So it's those divergences that we're starting to really see. And this is data right from GLERL, which is the Great Lakes Environmental Research Lab. But you're seeing in Lake Superior and Lake Erie the actual record-setting water levels this summer in the little red bars at the end there. So new record set, right? And it's just environmental conditions are changed. This is a note by Dr. Drew Gronwald, a person I've been lucky enough to sit down and have beer with and talk about Great Lakes hydrology. But basically what we're expecting is just these rapid transitions. 2013, extreme low. 2018, extreme high. 2019, right? It's that short period of swing that we're going to have to start getting used to. And that'll be down low again. Next year, though, I think we're going to be higher, maybe even than we were this year, because we're going to end this year higher than we started last year. So this is the real thing to take. Conditions around the Great Lakes are no longer, previous historic conditions are no longer a good basis for you to make any decisions on, because things have changed and are going to continue to change. And so my grandfather used to see things, 40 years or 80 years or whatever years ago, doesn't matter, because it's totally re-engineered. It's a new system, and we as scientists are now trying to grapple with how we measure things that we expect to see, and then go out into the field and do our measurements and say, how the heck did that happen? What happened? Up here, Muskoka Lakes, even upstream, it's not just in Georgian Bay. Those increasing storm conditions are flooding properties out. The Bracebridge overtopping this spring, right? There's just more water than we've ever engineered for, as David was saying, those infrastructure things. And here is an example of a single point failure on the Trans-Canada Highway at Wawa in 2014. The entire road washed out, and that is the only road, that is the only highway there, right? That was a culvert failure, but it's not because of hardened city infrastructure, right? That washout occurred because the soil saturated, because the water in the storms, there was too much water, even Mother Nature, all around, didn't have the capacity, even with 100% natural infrastructure intact, there was not the capacity to withstand that change in the hydrology, in what happened. So we have our hands cut out for us if we think we can just engineer our way around it. We really need to talk about getting rid of these things. And one of them, as David pointed out and as Julie talked about, was really looking at mapping and updating the maps to look at floodplains. So those things typically look at 100-year flood conditions, so that's the fluvial flooding, but they don't really capture the pluvial, the precipitation-based flooding. You can be up in the higher ground in a town or in a city and still be flooded out because of that increased precipitation. So these maps are being updated, and they're using satellite imagery and bathymetry and North Bay and Parry Sound, just as some examples of the state of the art in mapping that's starting to come out. These are 20-meter resolution squares. But again, it was mentioned, we're seeing our soil is already pre-saturated. There's already water in the soil. And so when the rain happens, it can't sink into these spongy soils. They're already full. It just starts running off. So what we're concerned about is really looking at doing more research to understand the threat. Because it's changing, you don't even have the ability to tell engineers now what's going to happen in this particular area. So there's a lot of science still to do. Educating the community about the causes and consequences, which we're going to see more and more. And like it or not even, I think, you know, aspirationally, you heard Greta Thunberg, the young Swedish activist, talking about trying to get people to take action. And the IPCC reports, the Interparliamentary Commission reports on climate change, talking about 1.5 degrees global temperature increase. If we act right now, and we have now only 8.2 years left to act, because that carbon budget, we were using it up faster than they predicted. Even if we act, that's to have a 50% likelihood of only hitting 1.5 degrees Celsius increase. If we go over that and the Arctic ice all melts and the insulation, the sun hits that and warms the permafrost up even faster, and that releases more methane, which we can't even hope to stop, those things start to run away. Those are the feedback loops that really create some catastrophic conditions. We could be easily looking at 6 degrees by the end of this century if we don't really start to get serious and take action on how to mitigate this problem. And if we stop today, we'll be lucky if we hold everything. If it all stopped today, we'd be lucky if we hit 1.5 degrees, right? So it is an alarming condition. Working with volunteers and other organizations, and I think it was well pointed out that partnerships and collaboration are needed, and encouraging really individuals. So it's we don't have time to wait for municipal governments to act. We don't have time to wait for federal governments or provincial governments to act. We ourselves, as consumers, we need to take these actions immediately. And the biggest thing that you can do isn't to put necessarily solar panels on the roof of your house, is to start consuming clean energy with things like an electric vehicle. That 30% of the problem right now is transportation, personal vehicles. Up to 70% is all of the cost of energy and transportation. If everybody went out in Canada and bought an electric vehicle, it wouldn't solve the world's problem. But since we are about the third highest global producer per capita in Canada of greenhouse gases, we're third. You can't look at somebody in Kiribati whose country is sinking under the Pacific Ocean, or somebody in Bangladesh whose fields just got flooded by seawater that even when the seawater goes away leaves the salt behind and they can't grow a crop anymore, you can't look at them morally in good conscience and not say to yourself, why am I driving that gas guzzler out there? Why aren't I taking a little bit of pain and actually making that change? So I'm encouraging everybody over the next 8 years, put that in your plan, start to actually take it upon yourself to act. Don't just think I can push it on a government or somebody else's shoulders. Individuals have a huge way of making a change and making a difference, and Canada, as an educated, affluent country, has a huge role to play in that. This is our new tool. We will be able to tell you everything about the water in Georgian Bay. It's an autonomous underwater vehicle. It's a $350,000 machine. We bought it with 3 other universities. We will be able to tell you everything anybody ever wanted to know about the waters in Georgian Bay or the rivers that we can drive it up. That's a new fun tool. We called it Georgie McBayface, GBF, but you might have heard of Bodie McBoatface, which is the UK's instrument in the Antarctica, so in homage to them. And this will be a really exciting tool for us, and we're looking for collaborations with anybody, municipalities, governments, other NGOs, organizations that are NGO-like but not formally NGOs, like Severn Sound Environmental, who we love to work with. We will be able to tell any decision maker any bit of data they ever want to know, right? It's up to you as citizens to take action directly and also demand that the elected officials do what you tell them. Just images of what it'll look like. I want to finish with these 2 last slides. Global warming is not an abstract threat. It's real. It's happening right now. We are feeling its impacts. They're apparent, and we're not ready for them, so they're negative right now. But public complacency is not an abstract threat either. We have been too complacent. We are not as alarmed as we should be. We should be much more alarmed, and public complacency is actually causing a lot of this grief because we're not demanding action yet. We're not taking that stand that we really need to take as if it is a crisis and it is an immediate threat to ourselves and our families and our future families and our global family. Thank you.